Question 1. What is the primary architectural goal of adopting a multi-tier design pattern for cloud applications? Option A. To tightly couple all application components into a single, indivisible unit for faster deployment. Option B. To simplify database management by consolidating all data into a single, centralized server. Option C. To achieve separation of concerns, independent scalability, and improved fault tolerance and maintainability. Option D. To eliminate the need for load balancers and CDNs by distributing logic across all servers. The correct answer is to achieve separation of concerns, independent scalability, and improved fault tolerance and maintainability. Here's the explanation. The Overview section states that the primary goal of multi-tier architecture is to achieve separation of concerns, enhancing scalability, reliability, security, and maintainability by distributing responsibilities across distinct layers. Question 2. In a typical three-tier cloud application architecture, which of the following components would primarily reside within the application tier? Option A. Web servers and content delivery networks, CDNs. Option B. Load balancers and user interface, UI. Option C. Application servers, API gateways, and message queues. Option D. Relational databases and object storage. The correct answer is application servers, API gateways, and message queues. Here's the explanation. The key features components, section lists, application servers, API gateways, and message queues as core components of the application tier. Backend/business logic. Options A and B relate to the presentation tier, and D relates to the data tier. Question 3. When a user initiates a request for dynamic content in a multi-tier application, which sequence of interactions accurately describes the flow through the tiers? Option A. Client to CDN to database to application server to web server to client. Option B. Client to load balancer to web server to application server to database to application server to web server to load balancer to client. Option C. Client to application server to database to web server to load balancer to client. Option D. Client to database to load balancer to web server to application server to client. The correct answer is client to load balancer to web server to application server to database to application server to web server to load balancer to client. Here's the explanation. The How It Works section details this flow. The client request hits a load balancer, which forwards it to a web server. The web server passes dynamic requests to an application server. The application server interacts with the data tier, database, processes the response, sends it back to the web server, which then sends the final response back through the load balancer to the client. Question 4. A company needs to move its on-premises virtual machines to AWS as quickly as possible to meet a data center exit deadline, with minimal changes to the application architecture. Which of the 6 rupees migration strategies is most appropriate for this scenario? Option A. Refactor/re-architect. Option B. Repurchase. Option C. Rehost, lift and shift. Option D. Replatform, lift and tinker. The correct answer is rehost, lift and shift. Here's the explanation. Rehost, also known as lift and shift, involves moving applications to the cloud with minimal or no changes to their architecture, typically by migrating VMs as is to IaaS. This is the fastest way to migrate when speed is the primary driver and minimal changes are desired. Question 5. An organization is evaluating its application portfolio for cloud migration. They have an outdated, custom-built CRM system that lacks modern features and requires significant maintenance. They decide to replace this system with a leading cloud-based SaaS CRM solution. Which of the 6 rupees strategies does this decision represent? Option A. Rehost. Option B. Re-platform. Option C. Repurchase. Option D. Retire. The correct answer is repurchase. Here's the explanation. Repurchase, drop and shop, involves replacing an existing application with a cloud-native SaaS solution that provides similar functionality. This eliminates the need for migration and reduces operational overhead. Question 6. A company has a legacy monolithic application that is struggling with scalability and agility during peak loads. They want to fully leverage cloud-native capabilities, break down the application into smaller services, and improve resilience. Which migration strategy should they primarily pursue? Option A. Rehost. Option B. Replatform. Option C. Refactor/re-architect. Option D. Retain. The correct answer is refactor/re-architect. Here's the explanation. Refactor/re-architect is the most transformative strategy involving redesigning and rebuilding an application using cloud-native features and services, e.g., microservices, serverless, containers, to fully leverage the cloud environment for increased agility, scalability, and resilience. Thanks for watching. Please subscribe to my channel.